This is a look at a weak acid strong base titration at a particulate level to see what is going on during the titration. And we are titrating a weak acid, that's our analyte, the thing we're analyzing, with a strong base, that's our titrant, the thing that we are adding. And first of all, a point of clarification. If we look at a representation of weak acid, in this case HA, you'll notice that almost all of the molecules are not dissociated, but out of the more than 100 molecules depicted here, one is dissociated. If we were to look at a piece of this solution, a small piece, we'd largely see, maybe only see, undissociated HA molecules. And so for most of the representations, we'll be just showing the predominant species, the things that are in high concentration. In this case, it's HA. We also won't be showing water, which is sort of depicted by this light blue background. Okay, so before any titrant has been added, we simply have, as the predominant species, HA molecules. And so here's our sort of molecular level depiction of this. Yes, there is a little bit of H plus and A minus, but it's largely HA. Okay, we start titrating, and when the OH minus ions enter the solution, they'll encounter HA molecules. They'll react with them. The reaction is that HA and OH minus react to make the conjugate base of the HA, A minus, and water. So essentially the hydroxide's grabbing an H plus off of the weak acid and converting it into its conjugate base. And so after reaction, we have a little less HA and a little more A minus. Okay, continue titrating. Another OH minus reacts with another HA, removes the H plus, converts the HA into its conjugate base, and we have a little less HA and even a little more A minus. And you might notice that if we have a solution that has some weak acid in its conjugate base, and they're in reasonably significant and not too dissimilar concentrations, we have a buffer. So we keep titrating, this reaction keeps happening. Another OH minus converts an HA into its conjugate base. Relatively equal amounts of weak acid in its conjugate base. So still a buffer as well. Continue. Another HA converted into A minus. And we're getting less and less HA, more and more A minus. Here, they're both still fairly significant concentrations, so we still have a buffer. We still have significant amounts of HA, and A minus is our predominant species. And then, if we do a little bit more, now we're down to very little HA, fair amount of A minus. We still have those as our two main species, but probably may not be a buffer at some point because we have too little HA. And then finally we add enough to have reacted with the last HA molecule. So all of the HAs have been converted into A minuses, and we're no longer moving towards the equivalence point. We've now reached the equivalence point because we've added enough OH minus to fully react with the HA, so the number of moles of OH minus added were equal to the number of moles of HA we started with. All of the HA has been converted into A minus, so we're at the equivalence point. The predominant species, other than water of course, is the weak base A minus. The solution is going to be basic because of that. And then if we add more OH minus, we now move past the equivalence point. The solution will be more basic, and we still mostly have A minus, but we're now getting more and more significant concentrations of OH minus, and the solution will get much more basic as we move past the equivalence point. And that is it.